Let's say I have a topology like this: router 1, router 2, both are directly connected, and we are using EIGRP protocol here. This is nothing but my router 1 R1. This is R2. Here we are running IP, let's say 12.1. Here I am running IP 12.2. Let's say router 1 have one network 10.1.1.0/24. Okay. So router 1 will share this network information with router 2 through update message. Right? Router 1 will send one update message to their neighbor. Right, in the update message, this update message will carry this network information 10.1.1.0/24. After that, router 2 will install this network in topology table first, in topology table, and then in routing table. Right, R2 will install with symbol D 10.1.1.0/24 is reachable via R1. Is reachable via R1. Now guys, let's say after some time, if this loopback or this LAN network will goes down, let's say this network is goes down. So it is responsibility of R1 to inform R2 to remove this network from their topology table, from their routing table. Yes or no? Otherwise, how router 2 will came to know that this network is not available on router number 1 now? Yes or no? So it will send one query message. Query message to R2. The main purpose of query message is to inform neighbor that if you have installed 10.1.1.0/24 network via me, please remove that entry, because now delay from my side is infinity for this network. It will set delay infinity for this network, and then it will send update message to router 2. That is query message. Okay. And if router 1 is sending query message with delay infinity, that means router 1 is asking for this network also to router number 2. Done. And when router send query message to any neighbor router, then state of that network will change, guys. By default, state of network in topology table is passive. And if router have sent any query message for that particular network, so state of that network will be active. Active state means router is waiting for the reply message. It have sent the query message for this particular network. So when router 2 will receive the query message, right, router 2 can send either positive reply or it can send the negative reply. It will send the reply message. In reply message, maybe router 2 will share one path. If router 2 have alternate path for this network, if router 2 don't have a path for this network, it will send negative reply. Then router will discard this network from the topology table. But until and unless router will not receive reply message, this network will be there in the topology table of router 1, and state will be what? Active. State will be active.
Sir, can you sir repeat again?
Yeah, I am going to repeat it. Let's say here I have one switch. Between router 1 and router 2 I am using network 12.1.1.0/24, and here in LAN let's say I am using network 192.168.10.0/24. Done. Now I am going to configure EIGRP between router 1 and router 2. So when we will configure EIGRP, router 1 will share this network information to R2 through update message. It is clear to everyone. Yes, it should be clear. Okay, config T. First of all, let me configure the IP interface F0/0 no set, and here I am going to configure IP 192.168.10.1 255.255.255.0 exit interface F1/0 no set, and IP address 12.1.1.1. Done. I have configured the IP address on router 1. Let me configure IP on router 2 as well. Same time. Config T interface F0/0 no set, and IP address 12.1.1.2 255.255.255.0. Done. Do ping 12.1.1.1. So there is connectivity between router 1 and router 2. Now I am going to configure EIGRP router. EIGRP AS number, let's say I am using 10, and network 12.1.1.0, say no auto summary. Done. Let me enable EIGRP on router 1 also. Router EIGRP AS number 10 and network 12.1.1.0, no auto summary, and network 192.168.10.0. Done. So IP EIGRP topology. State of both network is what, guys? Passive. Passive means my EIGRP topology is stable, and active means it is waiting for the reply message. Whenever you will see the state of a network in topology table is active, that means router have sent the query message for that particular network. In the same way, router 2 will also learn this network. So IP EIGRP topology, here also you can see state of this network is passive, and this router can ping 192.168.10.1. Ping 192.168.10.1. Done. Now I am going to capture the link here, this link. And now I am going to down interface F0/0 of router 1. So when this network will goes down, first of all, see this network is directly connected on router number 1. So router will remove the entry from their topology table immediately. So here I have the capturing, and it will send one query message. Config T interface F0/0 and say shutdown. Are you able to see the query message here? Let me stop the capturing.
Yes, sir.
So see, in this query message, source is query message is multicast. Query message is multicast. Source is 12.1.1.1 and destination is 224.0.0.10. If you will open this query message, so in this query message, guys, see here network is 192.168.10.0 and delay for this network is infinity. Delay infinity means there is no reachability. This is worst path. right? So if you have any, reachability or any alternate path for 192.168.10.0, then give me. If you don't have any path you have learned via me, then please uninstall it. Remove it from the table. Getting my point? And after that you can see the reply message. Reply message is unicast or multicast? Reply message is unicast.
Unicast.
And this is acknowledgement of query message. So router 1 have sent the query message, then router 2 have sent the acknowledgement message, then router 2 have sent the reply message, and then router 1 have sent the acknowledgement message. In the reply message, router is sending what? This network, and delay infinity. That means router 2 does not have any path for alternate path for 192.168.10.1 10.0 network. This network. Getting my point? So what I am saying, that whenever this network bill goes down, right, router 1 will send query message for two purpose. One, if you have learned from me, so uninstall it. If you have alternate path, then please share with me also. Okay. Now what I am going to do, I am going to say again no set here, and I am going to create one loopback on router number 2 with same IP address. Interface loopback 1 IP address is 192.168.10.1 255.255.255.0, and router EIGRP 10 network 192.168.10.0. Now this router have also same network, so IP EIGRP topology. In the topology table it have installed this network, and so IP route EIGRP. It have not learned any prefix from EIGRP, right? And router 1 have also same network, so it will not learn from router number 2. So IP route EIGRP, it have directly connected network, so that's why you can see the routing table of EIGRP is empty. So IP EIGRP topology. So this time if this network will goes down, again router 1 will send the query message. This time router 2 will send negative reply or positive reply?
Positive.
This time router 2 will send positive reply, because this time router 2 have path reachability to 192.168.10.0 network. Again I am going to capture this link, and again I am going to don interface f0/0 of router 1, interface f0/0, and say shutdown. Query message and reply message. I am interested to check reply message only. In reply message, this is the network, and delay is not infinity. Delay is this one. Yes or no? So this time router is sending bandwidth plus delay. So router 1 will install path via router number 1. So IP EIGRP topology. In the topology table you can see next hop is 12.2, and so IP route EIGRP you can see. In topology table, state is passive. Now how we can see active state in topology table? We can do one thing. See, whenever router is sending query message, it will wait for 180 seconds for the reply message. 180 seconds for the reply message. For the acknowledgement, you already know that it will send 16 time unicast message if router will not get acknowledgement, right? But if router will not receive reply message within 180 seconds, then it will stuck that network in active state. That is stuck in active state. This is also a concept of EIGRP, stuck in active state. Stuck in active state means when router will send the query message, it will put that network in active state, and if router have not received the reply message, so it will put that network as stuck in active. And whenever a network goes in stuck in active, so router break the neighborship. Let's say router 1 have sent one query message to router 2 and router 1 have not received the reply message within 180 seconds. So router 1 will break the neighborship with router 2. Okay. Okay guys. When 192.168.10.0 network goes down on R1, first R1 will remove the entry from their routing table, then it will send query message and state will be active. Active means I have sent the query message of that network and waiting for reply message. What I am going to do, see here, first of all I am going to up the interface F0/0, say no set, and I am going to apply one access control list on router number 2, so that when router 1 will send query message, router 2 will not give reply. So let me take you to router number 2, and here I am going to apply one access control list. So if anyone know the access control list, tell me. Here I need to configure which access list, standard or extended.
Standard.
No, through a standard ACL we cannot achieve. Actually I want to filter EIGRP traffic. Through a standard
Then
access control list
extended.
we can filter the IP packet directly. Yes or
Yes, yes,
no?
sir.
So access list, after that access list number 101 deny 88 is the protocol number of EIGRP. Then host source will be 12.1.1.1 and destination is, let's say, NE. After that access list 101, same with permit statement, permit IP NE NE. I will apply this access control list on which interface? Interface F0/0
F00 in. F0/0 in or yes.
IP. Okay, access group 101 direction in. Before applying it, here I have capture. Yes, I have capture. Now I will apply this access control list over here, and then I will down the router 1 F0/0 interface. First let me apply it, and then I am going to say shutdown. I have sent show IP EIGRP topology. See, the state is what? State is active and neighborship is here
Down.
down.
Broken.
Yes. And again EIGRP neighborship is formed. And here in the capturing you can see router 1 is sending query message again and again, but it is not receiving the reply message.
Sir, also in that message on that router command line, FD became infinity, sir.
Where?
Just scroll up. In this, yeah.
Yes, FD will
FD is
also
in,
become
yeah.
infinity.
Yeah, okay.
Q count will also increased.
Yes, Q count will be more than 0.
Yes. Here this state is active, and if it will not receive the reply message, active state means I have sent the query message only. It will stuck inactive when it will not receive the reply message. So it is not receiving the reply message, that's why it have broken the neighborship, and then again it have formed the neighborship. So this is how query message and reply message work. Let's say I have a network like this, not like this. Let's say I have a network like this. I have some router R1, R2, R3, and R4. And I have one switch over here. And on this switch, we have one LAN network. Like this. R1, R2, R3, R4. Here I have this is switch, and here I have one LAN. Let's say 192.168.10.0/24. So router 1 will learn this network via router number 3. Yes or no? Router 1 will learn 192.168.10.0 network via router number 3. Via router number 3. Yes or no? But there is one more path available via router number 2. So always keep in mind, if in the topology table feasible successor is available, then router never generate query message. R2 via R2 also one path is available in the topology table, but this is feasible successor, let's say. So if feasible successor is available for a network and then that route will goes down, then router will not generate query message. Sometime interviewer can ask you like question that how to stop the query message. So if you want to stop the query message, one option is we can perform the summarization. Later on we will discuss that also. But here try to understand that if we have feasible successor in the topology table, then router does not generate any query message. So router will generate query message in only scenario when feasible successor is not available for a particular network and that network goes down. Done, guys? When this link will goes down, let's say this link is down. Now here router 3 have learned 192.168.10.0 network, right? And state is passive. So once this link will goes down, here state will become active. It will send one query message to R2. R1 will send the reply message and it will learn 192 again P 192.168.10.0 via router number 1. Okay, one second. Okay, in this scenario, when router 3 will send the query message to R1 and R1 have learned same network 192.168.10.1 via router number 3. So do you think router 1 will generate reply message directly? No. Router 1 will not generate reply message directly. First router 1 will send also one query message to router 2. Query message. And router 2 have path via router number 4, so it will generate the reply message. Reply. And then router 1 will give reply to router 3. So if router 1 will take more than 180 seconds to give reply to R3, so R3 will break the neighborship with R1. Okay, this is the concept of query and reply. Done? Is it clear?
Sir, but say for example, when R3 link is down with the switch, Okay.
Okay.
And yeah, it will send R3 will generate a query message telling R1 that I have lost this particular route
Yes, delay
and
is
kindly
infinity
flush.
from my
Yeah,
side.
yeah. So, but in R1's topology table, it will learn path via R3 and R2, correct?
Yes,
Then
correct.
why R1 needs to send query for that particular route
Because let's say
again to R2?
R1 have route via router number 1. Sorry, via router number 3.
Yes.
And the path, this path is not available now. So R1 also need to find the alternate path. Yes or no? R1 need to find alternate path. R1 don't know. Let's say R1 have one feasible successor via router number 2 and the successor via router number 3. So in this scenario, R1 will not generate query message.
Yes, sir, that is my query, because if it is having a feasible successor through
Yeah,
R2, then it
then
will not
definitely
generate no.
router will not generate the query message. But let's say
Okay.
router 1 don't have the feasible successor.
Okay,
Router
then it
1
will
don't have
generate.
the feasible
Yes.
successor. Yes. Okay. Neeraj,
Yes, sir. Yes, sir. Got it.
anything else? Any doubt, guys? Any other question? Otherwise, we are going to discuss EIGRP neighborship type. We have two types of neighborship in EIGRP. One is static and one is dynamic. So till now we have discussed dynamic neighborship. Yes. And now we are going to discuss some example of static neighborship in EIGRP. Like I have a topology, see, like this. Router 1, this router is connected with one switch, or you can consider this as ISP. This router is connected with internet, and this is my headquarter, and these are my branch office. If I have a topology like this is my topology. R1, R2, and R3. This is switch, or you can consider it as internet as well. Let's say we have the VPN. Later on you will understand. Here EIGRP neighborship, how many EIGRP neighborship will be there of router 2, guys? 2, right? There will be one neighborship over here with router 1 and one neighborship with router 3. Here also we will have one neighborship, and this is full mesh topology. Yes or no? All devices or all branch or all routers are directly connected with each other. Yes or no? So this is full mesh topology. Full mesh topology. Now here, if you want to make hub and spoke topology, hub and spoke topology means you want to form neighborship between router 1 and router 2 only, and between router 2 and router 3 only. Then you need to configure what? Static neighborship. Then you need to configure static neighborship. Otherwise, if you will configure EIGRP, so it will form neighborship between router 2 and router 3 also. Right? And command is very simple to configure a static neighborship. Let me show you. Let me delete this topology and let me design one more topology over here. R1, one switch, and we have again two router. Here we have some concept of distance vector routing protocol. So try to understand, guys, the scenario first. This is 0/0. Here I have one LAN. LAN is okay. Here I am using network 192.168.168.10.0/24. I will configure dot 1 on router 1, dot 2 on router 2, and dot 3 on router number 3. Done. You in upcoming day you will understand that this is not switch. This will be the ISP internet on or internet. We will have the VPN tunnel. On the tunnel we will use this IP address. Now I am going to configure this IP address directly on the physical interface. And let's say router 1 have one LAN network, that is 10.1.1.0/24. Router 1 have one LAN 10.1.1.0/24. Router 2 have one LAN 20.1.1.0/24, and router 3 have one LAN 30.1.1.0/24. 30.1.1.0/24. Let me configure this topology first. IP address. R2 R3. First of all, here I am going to configure the IP interface F0/0 NOSUT and IP address 192.168.10.0 10.1 255.255.255.0 exit interface loopback 1, and here IP address is 10.1.1.1 255.255.255.0. Done. I have configured the IP address on router 1. Let me configure IP on router 2, guys. Config T interface F0/0 NOSUT IP address 192.168.10.1 255.2 not 1 2 here 2 and 255.255.255.0 exit interface loopback 1. IP address is 20.1.1.1 255.255.255.0. Let me configure IP on R3. Config T interface F0/0 NOSUT and IP address 192.168.10.3 255.255.255.0 and exit interface loopback 1, and IP address over here is 30.1.1.1 255.255.255.0. Now I am going to configure EIGRP. See, I'm not going to configure EIGRP dynamic neighborship, because here, as you know, I want to form hub and spoke topology. Means spokes or branch offices should be connected with hub router only. Means if let's say this is my branch 1, and when branch 1 want to communicate with branch 2, traffic should go via hub router. Let's say this is my headquarter or main office, hub router. Okay, so here we will form EIGRP static neighborship. My topology should be like this, right? If 20.1.1.1 want to communicate with 30.1.1.1, it will communicate via hub router. Okay, so we need to configure a static neighborship in EIGRP. Router EIGRP ES number 10, and after that we will say neighbor, then IP address of neighbor 192.168.10.2 192.168.10.2, and on which interface this neighbor is available on fast Ethernet 0/0. That's it. You need to run this command, and there is one more neighbor 192.168.10.3 on same interface. Okay, after that I am going to advertise network. Which network I need to advertise? 10.1.1.0. Wildcard mask 0.0.255. And let's say yes, no auto summary. Done. Now let me take you to router number 2. Router EIGRP has number 10 and neighbor 192.168.10.1 on which link on F0/0. Network 192.168.10.0. See, you have to advertise this network also on router number 1, because until and unless you will not advertise this interface, means this F0/0 in EIGRP, this interface will not join the multicast group. Yes or no? So on router number 1 also we need to advertise this network. Router EIGRP 10 and network 192.168.10.0. Wildcard mask if you want to mention, so you can mention, right? And here also I am going to advertise this network and network 20.1.1.0 0.0.255. Done. Now see, there is one neighbor, so IP EIGRP neighbor 192.168.10.1 is the neighbor. Yes or no?
Yes, sir.
And this router have learn any network, so IP route EIGRP. Yes, 10.1.1.0/24. Now I am going to configure EIGRP on router number 3, guys. So on router number 3, let's say router EIGRP is number 10 and neighbor is 192.168.10.1 on F0/0 interface. Network 192.168.10.0 0.0.255 and network 30.1.1.0 0.0.255. Okay, so IP route EIGRP. Now this router 3 have received 10.1.1.0 network. Why router 3 have not received 20.1.1.0 network? This is first question. Why router 3 is not receiving 20.1.1.0 network? In the same way router 2 is also not receiving 30 network, 30.1.1.0. And if you want to see the routing table of R1, so see R1 have received, so IP route EIGRP both 30 and 20. So can 20.1 ping to 30.1? No, it cannot ping. Yes or no? From hub router I can ping 20.1.1.1 and source is 10.1.1.1. It will work. I can ping 30.1 also. 30.1.1.1 source this one. And so IP EIGRP neighbor, there are two neighbor. 192.168.10.3, 192.168.10.2. For both neighbor you can see SRTT time is different. Yes or no? RTO time is also different. Okay, let me take you to router number 2 and here so IP EIGRP neighbor, you can see there is only one neighbor. And so IP route EIGRP. Now this is question, guys, that why router 2 is not receiving 30 network. Please tell me. Ping 30.1.1.1 source 20.1.1.1. What is the problem? What is problem?
Because you haven't built the neighborship.
Where?
Because
so router 2 is advertising 20 network to R1 and R1 should advertise it to their neighbor, na?
Yes, sir.
But why R2 is not advertising? Hello. Yes, Nirav. Okay. Router 1 is receiving 20 network on which interface? On F0/0 interface. Yes or no?
Yes,
What
sir.
is the split horizon rule, guys?
Yes, it will not send the update from the interface it has received the update.
Exactly. A split horizon means a split horizon is by default enabled, so it is receiving update message for 20 network on F0/0, so it will not advertise same network from the same interface. So here in this scenario I need to disable a split horizon.
Horizons.
Once I will disable a split horizon on router number 1, go to interface F0/0 and say no IP split horizon for EIGRP ES number 10. After running this command, you can see the routing table of router 2. So IP route EIGRP. Now it is receiving 30 prefix. Yes or no? It can ping as well. Ping 30.1.1.1 from 20.1.1. Ping is working. Yes or no? And if you will trace route 30.1.1.1 and source is 20.1.1.1. So my traffic is going via router 1. Yes or no? So what I want, that whenever branch office need to communicate with each other, they should communicate directly. EIGRP neighborship should be with hub router only. But when branch offices want to communicate with other branch office, they should directly communicate. How I can achieve it? What is happening? How I can achieve it? See, now I am tracing the traffic and I am able to see that router 2 is able to ping 30.1.1.1 via router number 1 because so IP route. So IP route EIGRP. Because see, this router have learned 30.1.1.0/24 network via next hop IP address is what? 192.168.10.1. Actually, whenever router advertise the received prefix from the neighbor, it update their next hop IP address. It will put next hop self IP address. So actually when router 3 is advertising 30.1.1.0/24 network to router number 1, source IP address will be what in the update message? Here guys, when it will router 3 will generate an update message to share which network? 130.1.1.0/24. In this update message, source IP will be what? 192.168.10.3 and destination will be what? 192.168.10.1. Okay. When router 1 will receive it, it will change the next hop IP address. Here next hop IP address will become what? When it will advertise to router 2. Update message, network information is same, but it will change the
Source IP destination.
source IP address.
Yes.
Source will become what here? 10.1
10.1.
and destination will become what over here? 10.2.
2.
It is advertising to this neighbor. Right? So actually router 1 is updating next hop self. I can tell to router 1, please do not update next hop self whenever you are advertising a prefix to their neighbor. How? IP, say no, IP next hop self for EIGRP 10. Now it will advertise the prefix directly without modifying the next hop IP address. So now if you will check the routing table of router 2, so IP route EIGRP, now you can see next hop IP address is what? 10.1.1.3. And if you will trace route 192.168.10.3 and source is 20.1.1.1, not this one, sorry, 30.1.1.1. Trace route 30.1.1.1 and source is 20.1.1.1. Now it is forwarding traffic directly to R3. Yes or no? In the same way, R3 will also, so IP route EIGRP, you can see 20 network and next hop IP address is 10.2. So now router 1 is not modifying the next hop IP address. So from here also, if you want to trace route 20.1.1.1, you can trace route. Source is 30.1.1.1, say numeric. See, traffic is directly forwarded to router number 2. Done. Is it clear to everyone? Any doubt here? See, in this type of scenario, we need to configure a static neighborship in EIGRP.
Sir,
So
but
this is concept.
say for example, in this type of scenario, router R1, R2, R3 would be supposedly the end routers, correct? They
Okay.
won't be having, like, say for example, R3 won't be having any other router connected to it ahead,
Okay.
correct? Like it will behave like a stub. If then only it is possible. No, otherwise there can also be a looping problem, I guess.
Exactly. So here we need to configure stub as well, brother.
Yes, sir.
See,
That.
if this network 20 network will goes down, R2 will generate the query message
Yes, sir.
for their neighbor,
Yes, yes.
and router 1 will generate query message for R3.
R3.
But this is not true because router 1 have advertised this network to R3, and now router 1 is sending the query message. Yes or no?
Yes, yes. So in real scenario, stub also needs to be configured with this
Yes,
static
here we need
configuration.
to configure stub as well.
Okay, okay.
Anything else, guys? To anybody? Rohit? Hello, Rohit. Am I audible?
Yes, sir. No question, sir.
No question. So here, whenever any branch network will goes down, R1 will generate query for, let's say this network is down. So R1 will generate query for R3. So that is not good because R1 have advertised 20 network to R3. So here we need to configure a stub. What is the concept of a stub network, Nirav? What will happen when we will configure a stub?
Sir, I just know what the stub means in as per networking. It means that there is no router ahead. So this is the last edge router. Other than that,
Exactly.
only LAN is available.
Exactly. Great. So this is the last router. So here we will configure EIGRP. Just we need to run this command EIGRP stub. That's it. On router 2 also and on router 3 also. Config T router EIGRP 10 and then EIGRP stub. That's it. So IP route EIGRP. So now we have discussed two types of neighborship in EIGRP, static and dynamic. Now we need to understand load balancing in EIGRP. See, these are the concept. So we are discussing one by one all concept, right? After that, I will combine everything together. Okay. So loop avoidance mechanism in EIGRP. Guys, here I have one router R1. R2, R3 and R4. R1, R2. I have this type of topology in EVNG. Let me start EVNG also. R4. And here R4 have one network. Let's say same network 192.168.10.0/24. Okay. And bandwidth of this link, oh sorry, metric on this link is, let's say 5. Metric on this link is 10. Metric on this link is 20. Metric over here is 15 and metric over here is 15. So router 1 have two path for 192.168.10.0/24 network. One is via router number 2 via R2. And what will be the metric? What will be the metric over here?
35.
35, and it have one alternate path, one more
35.
path, 192.168.10.0/24, reachable via router 3,
Yes.
Yes,
R3,
yes.
and here metric is
35
35.
again.
35. So from both side metric is same. So router will perform what? Load balancing
Load
over here.
balancing.
And this type of load balancing is called equal cost
Cost
load
load.
balancing. Equal cost load balancing. Because cost on both link is same. Balancing. But EIGRP is the only protocol which can perform unequal cost load balancing as well. What I am saying? EIGRP is the only protocol which can perform unequal cost load balancing. Let's say now I have, okay, equal cost load balancing, first of all clear, because equal cost, in equal cost load balancing, whenever router receive a prefix from multiple side with same prefix length, same AD value and same metric, then router install both path in their routing table. That is equal cost load balancing. It is very simple and very clear. Now let's say here metric is not 15, metric is 10 over here, 10. So via R3, what will be the metric on router number 1?
30.
30. Here now metric is 30. Okay. So tell me, in the topology table of R1, how many path will be there in topology table?
Two
path.
path.
Because alternate path is feasible successor or not, first you will check through feasibility condition. If feasibility condition will match, then it will install both path in their topology table with symbol P. 192.168.10.0/24 is successor, via router number 3.
3.
And there is one more entry, P 192.168.10.0/24 is feasible successor via router number 2. Yes. So this is the topology table of router 1, and in the routing table, it will install only best path, successor path. Routing table. If I will talk about the routing table, so in routing table there will be only one entry. Yes or no? That is, let me write here, 192.168.10.0/24 is reachable via R3. This will be the routing table. Yes or no? Now
Yes.
here in the topology table, whenever we have more than one path in the topology table and we have only one path in routing table, if you want to install both path in the routing table, you can install it by using a feature called variance in EIGRP. By using a feature called variance. So now question is, what is variance? So guys, it is used to perform unequal cost load balancing in EIGRP. It is nothing but the 7 bits value. It is 7 bits decimal value. So range will be
0 to 128.
range, not 0, 1 to 1
Okay.
to 128.
Yeah, sorry, 1 to 120.
128. It is applicable only on feasible successor. This is the point, okay? Only applicable on feasible successor. feasible successor. If alternate path is not feasible successor, then we cannot achieve unequal cost load balancing. Okay. So what this router will do, this router will multiply variance value into
FS.
variance multiply by FD of successor. FD of successor. It will get some value after multiplying FD of successor. Okay, so router 1 will get some value, yes or no? Let's say it have got value 40. So it will check the topology table. If in the topology table path is available with metric of 40 or less than 40, it will copy all routes in the routing table. What I am saying? If in the topology table alternate path is available who have metric of 40 or less than 40, router will copy those prefix in routing table. Getting my point? Dual algorithm will install all path which has lower value than multiplied value. And by default variance is what configure as 1. So now also variance is working. It will multiply variance value 1 multiply by FD of successor. FD of successor is 30. So value is what? 30. Router is getting what multiplied value? 30. So router is checking their topology table. In the topology table there is only one path available who have 30 metric or less than 30 metric. Getting my point, guys?
Yes.
Are you able to connect the dot now?
Yes.
So here I can design one more topology, or directly I can open the topology in EvenG. Let me open the topology in EvenG. Let me close the GNS3. So variance is nothing but a multiplier of FD. And then load balancing ratio will be what? If let's say router have installed two paths in their routing table, right, with different metric, then load balancing ratio will be what? So this is also a question. Ratio will be what? So it will depends on the value, multiplied value. Ratio can be 2:1. It can be, let me open this first. Root and Eve. Here I have already configured the IP address on all router. Let me turn on the device and see here. Here I am going to use only this topology. This I am not going to configure edge router. Okay, so don't worry. Let's say here we have some LAN network 40.1.1.0 to 40.1.5.0. Okay, so guys, let me configure all router EIGRP. Let me enable EIGRP on all router. Router 1, enable show IP interface brief, exclude unassign. So IP address is fine. Yes, Baljit. हाँ पढ़ा रहा था, बोलो ना क्या हुआ. हाँ 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 करता हूँ. Okay. Okay, so I have already configured the IP. Now let me enable EIGRP. Router EIGRP S number 10 and network. Can I run network 0.0.0 command? What will happen if I will run network 0.0.0 command, guys? It will enable EIGRP on all active
All that.
interface. Okay, so let me enable EIGRP on all active interface on router number 2 also. Enable config T router EIGRP S number 10 and network 0.0.0. Done. So you can see the neighborship. Let me enable EIGRP on R3 also. Config T router EIGRP S number 10 network 0.0.0. Let me configure EIGRP on R4. First of all, let me check the loopback. Loopback is here or not. So IP interface brief exclude unassign. So let me configure the loopback as well. Interface loopback 1 IP address is 40.1.1.1 255.255.255.0. Let me configure some more loopback. Two dot one loopback 3 3.1 loopback 4 and loopback 5. Exit router EIGRP 10 network 0.0.0.0. Okay, I am going to down interface F2/0 here. 2/0 shutdown. Okay, now router 1 will receive 40 prefix from two side. So IP route EIGRP. Yes, it is performing which type of load balancing? Equal cost load balancing, because cost you can see metric is equal from both sides. Yes or no? So by default router 1 is performing equal cost load balancing. From both sides you can see metric is equal. Done. Now what I am going to do, I am going to change the bandwidth over here on R3F1/0, because router 4 is advertising these prefixes to router 2 also and to router 3 also. Then both router will calculate metric and after that it will advertise to router 1. So here if I will change the bandwidth, so metric will be different. Yes or no? Guys, if I will increase the bandwidth, so metric will be lower or higher? Metric will increase or decreased if I will increase the bandwidth?
Decrease.
Decrease.
Bandwidth will, if bandwidth will increase, then metric will decrease.
Yes, sir.
Means bandwidth is inversely proportional to metric. Formula is what? 10 to the power 7 upon least bandwidth. So you can see it is inversely proportional. Okay, so what I am going to do, by default by default bandwidth on R3 is 100 Mbps. I am going to say I can change the delay, or I can change the bandwidth. So I am going to change bandwidth and let's say 10. Now see the routing table of router 1. It have removed the path via router number 3. Yes, because so IP EIGRP topology. In topology table also you can see there is only one path available. That means alternate path is not feasible successor. So what I am going to do, let me do one thing on here. I'm going to say bandwidth not 10 but bandwidth 99. Okay, so IP EIGRP topology all link. This is also a command. In all link also you will see successor and feasible successor only. Still alternate path is not feasible successor, so that's why you are not able to see the alternate path in feasible success in topology table. And so IP route EIGRP, you can see all 40s network is reachable via router number 2. On R3 I am going to set do so interface f0/0. This is the bandwidth, not 0/0, 0/1/0, 1/0. Here metric bandwidth is 99 in kbps, right? So let me do one thing here, bandwidth, and I'm going to say 12340 in kbps. Now you can check the topology table, clear IP EIGRP neighbor, and so IP EIGRP topology. Still only one path is there. Let me check, guys. This is the metric config T. Okay. On R3 I am not going to change metric. Say no here. Do so interface f1/0, and here now metric is default. That is okay, fine. And on R1 f1/0, here I am going to change bandwidth. Bandwidth 12340. So IP EIGRP topology. Now you can see there is two path available for 40 network. I have changed bandwidth on which interface? On f1/0. From both sides now metric is different. Yes or no?
Yes.
So router is not performing any load balancing. So IP route or so IP route EIGRP. It have installed only one path in the routing table and it have two path in topology table. So IP EIGRP topology. Yes or no?
Yes.
Yes, sir.
Here I want to achieve load balancing. So this type of load balancing will be unequal cost load balancing, because here you can see the cost is unequal of both path. So what variance value I should configure over here? Can anyone tell me what variance value I should configure over here? By default variance is so IP protocol.
Sir, feasible successor FD divided by successor FD will give you the variance value.
Very good. Exactly. So IP EIGRP topology. Here you will do what? You will divide.
389120 divided by 158720.
Exactly. So you will get what variance value. Let me check what variance value I should configure over here.
Approximately, sir, 2, I guess.
3891220 divided by 158720. Variance value should be what? 3. Variance value should be 3.
3. Okay.
Because you know why? What I tell you, that router or EIGRP dual algorithm will multiply variance value into FD of successor. After that it will check the topology table. It will compare the root with the multiplied metric and the metric which is available with root. Okay, so by default variance value is 1. Here we need to configure variance value 3, and command is very simple. Router EIGRP 10 and variance is
3.
3. I have set the variance value 3 and so IP route EIGRP. Now you can see it have installed both path in their routing table. Even metric is different. Even metric is different. So EIGRP is the only protocol which support this type of load balancing, unequal cost load balancing. No any other protocol can perform unequal cost load balancing. This is the biggest advantage of EIGRP. Here we can achieve unequal cost load balancing. Okay. Is it clear guys to everyone or not? Still, if anyone have confusion, please let me know.
Sir, when you change the bandwidth on R3's F10 interface in real world, it will impact, correct? Here in simulation, it didn't impact
We have
R1's.
offset list as well. You know, in real time, whenever you need to manipulate the bandwidth, you will be not allowed to change bandwidth and delay of link.
Sir, so for example, you set the band. Say for example, anytime we use the command to set a particular bandwidth. Say for example, by default it is 100 Mbps, and we are setting it to 10 Mbps. So, but that is logically we are setting, but the line rate at which the interface physically will perform will be 100 Mbps, correct? So, like, am I right or wrong? Like, say for
Yeah,
example,
yeah. No,
so
exactly right. You are right.
So virtually whatever bandwidth we are configuring is only for the calculation related to the routing protocol, whatever we are
Exactly.
configuring. But the
Yes,
line rate,
physical bandwidth is still
yeah,
100 Mbps.
yeah. Okay.
Now guys, I am going to change the variance value again. Let me remove the variance router EIGRP 10 and then say no. So again you can see so IP protocol variance value is what? 1. Now we have concept of offset list in EIGRP. Offset list. Through offset list also we can achieve load balancing, but that will be equal cost load balancing. Now see here on router number 1, let me show you the topology table. So IP EIGRP topology. For 40 network, we have 2 paths in the topology table, and in the routing table, so IP route EIGRP. In the routing table, we have only 1 path. Yes or no? So again, I want to perform load balancing because we have 2 paths in topology table. So we can achieve load balancing over here. So IP EIGRP topology. So what we can do through offset list, we can add some metric. It is used to perform equal cost load balancing. Offset list is used to perform equal cost load balancing. Offset list is used to perform equal cost load balancing. Let's say here I have a topology. Let's say this topology. In this topology, here let's say this is not the metric, this is not the metric over here also, and here also, and here also. Now let's say guys, router 4 is advertising this network 192.168.10.0/24, right, to router 2 and router 3. When router 2 is advertising to router 1 is calculating metric 100, and when router 3 is advertising to router 1 is calculating metric, let's say 150. So which path is best? Via router number 2, this path will become successor, right? And maybe this path will become feasible successor. But router 1 will install only one path in their routing table, right? So here if you want to install both path via router 2 and router 3 also, so through offset list we can add metric 50 over here. If I will add metric 50 over here, now you can see from both side metric is same. So we can achieve which type of load balancing?
Equal cost load.
equal cost load balancing.
Sir, but
To yes,
here, say for example, in offset, as you said, we will be adding 50, but in like real scenario, it is not actually 150, correct? We are adding 50.
yes.
So yeah, so we are manipulating it just like variance. But in case of variance, I guess we are not able
Variance is
to.
used to perform unequal cost load balancing, and offset list is used to perform equal cost load balancing. Here in the routing table, you will see cost of all paths will be equal.
No, no, sir. That's what I'm telling. That when you used the variance command, okay. So in that
Okay.
case, behind the scene, the routing protocol using dual, it was comparing that value using variance, but it was not that metric is not shown in topology table as equal. So
Hmm.
for that reason, we are considering it as unequal load balancing, correct?
Yes.
But here we
Yes.
are manipulating the metric itself, and that will reflect in the topology table as equal. So because of
Yes.
that, it will be considered as equal cost, I guess.
Equal cost load balancing.
Okay, okay.
Okay. So to apply offset list, first you have to define the interesting traffic. For the classification of traffic, I can use access control list. Through access control list, see, first of all, you have to identify that how much metric you need to add. Okay. Then we will create one access control list. Let's say 10, and permit. Whenever we are using access control list for the classification of traffic, we will create access list with permit statement always. So access list and permit 40.1. Let's say 0.0 wildcard mask 0.0.255.255. Done. In this match, all network will match, yes or no? After
Yes, sir.
that, router EIGRP AS number 10. Offset list. After that, offset list number, you can use any number from this range. So here we have create access control list number what? 10. So 10. After that, in which direction you want to apply? So I want to apply it in direction, because router 1 will receive 40 prefixes. Yes or no? Offset list 10, direction in, and after that, how much metric you want to add over here? How much metric you want to add? So to identify that how how much metric you want to add, you need to check topology table. So IP EIGRP topology. In topology table, you are able to see here metric is this one and here metric is this one, right? So you can subtract this metric from this. You can get what value? The value which you need to add in metric. Yes, guys. So let me open the calculator and let me calculate the value.
230400.
3891203838919120 and minus 158,872. This value. This value I need to add. So again I am going to say offset list number 10 direction in and add metric, this one.
Sir, in
Okay.
last it is 720.
720. It's 720, brother. Really?
Yes, sir.
I have not checked. Here it is 720. Yes, it is 720. So again I need to.
No, no, the value is 230400 difference.
What value?
230400.
230 400.
400. Yes,
This value.
difference. Yes.
Okay. So on router number 1, I am going to add this value 230,400, and after that you want to add this value on which interface? So on which interface I want to add? Fast Ethernet 0/0, yes or no? On Fast Ethernet 0/0. If I will add this metric on Fast Ethernet 0/0, so this metric over here and metric over here will become same, yes or no? Enter.
Yes.
After that again do so IP. Let me do one thing. Clear? Okay. So IP AGRP topology. Now you can see for 40 network we have not calculated the difference between metric correctly, brother. No, you have not. This is not the right difference. Yes or no? So IP protocol is the command to verify the filtering. So here you are able to see incoming route in Fast Ethernet 0/0 will have this metric added, this value added to metric if on list is 10. So what I am going to do, again I am going to check. So IP EIGRP, no, first of all let me remove the command router EIGRP 10 and say no to this, and do so IP EIGRP topology. Please calculate the difference correctly. It have only one path. Soon it is going to install both. Yeah, here it is. Let me calculate it. 389120 3838919120 minus 158720. I'm getting this value. This value is same. I think I have added this value only. Let me apply it one more time. Offset list, after that number is 10, direction in, I need to add metric 23, let me copy it, or 230,400 230,400, and it, which direction, on which interface, on F. I want to add this metric on F 0/0. Clear IP EIGRP neighbor, and so IP EIGRP topology. Now see, metric from both sides is same, so it will install both path in their routing table. Yes. Okay guys, and if you want to check the filtering, so IP protocol is the command. Here we have one filtering, right? List number 10, so we can identify, so access list number 10, so this is the access list, 10 match is there. Done. Clear?